PHP started up. This is awesome. So we've just reduced the IP address, reduced epoch, reduced microseconds from 32 to 20 bits, and then our random LCG value reduced from 64 bits to 20 bits. It's a total of 40 bits. This is awesome. This is something I can actually brute force. But wait, there's more. The great thing here is the PRNG, that random number generator, is separate from the cookie. So what if I actually brute force the PRNG separately, just those 20 bits, and I forget about the cookie for now? Well, if I brute force that 20 bits, and then I brute force this 20 bits, I'm not brute forcing 40 bits, I'm actually brute forcing 21 bits. For any value, for every bit that you add, you're only doubling the amount of work or the number of values. So because the random number generator is separate from the cookie, I can calculate this 20 bits within seconds, the code's online, and then brute force the other 20 bits, which if we recall 20 bits is approximately 1,000,000, and then brute force that cookie, accurately predicting the cookie for that person. Imagine if this were a bank and you were just brute forcing a cookie. On average, this means within 500,000 requests, I will get his cookie. I will get his session identifier and log in as him. Now, you can even do other stuff. So for example, what if you broke the random number generator and you went on a website where you forgot your password? Have you ever forgotten your password? You enter your username and they send you an email address. They send you an email and they say, hey, go to this random URL and you can reset your password from there. Well, let's say you said your name was the administrator, even though you're not. They emailed the administrator a random URL, but you just broke the random number generator. So you know exactly what that random URL is going to be. You then go to that random URL before the admin can, you reset their password, log in as them, change their email address so when they forget their password, it goes to you. And now you've just logged in as the admin, taken over that account. So this is pretty scary. You can do some crazy stuff with this. So the question is, how do we defend against this, right? How do we stop this from happening on our websites? Well, the first thing is upgrade PHP. Make sure you're using an up-to-date version. I notified PHP of this a long time ago, and they're very quick to fix it and very quick to add some more randomness. If you want, create your own session values. You can use something like, if you're on a Unix system, use dev-urandom to get some more random data. Facebook is not actually vulnerable. Sammy, why do you use them? I didn't want to get sued. That's why I use Facebook. Actually, what they do is they use something called hip-hop. So what they've done is they've taken PHP and they essentially take the PHP, convert it to, I believe, C++, then they compile it and execute bytecode. It kind of works like that, and in that process, they've adjusted their sessions. So they're not vulnerable to this attack. You're not going to hack into my Farmville. This attack is possible on other sites, so do make sure you upgrade your version of PHP. The new version has been out for months. Now at this point, this is awesome, right? I've broken into Robert's account. I can now do whatever I want as Robert. So why don't I message Anna? So what I'll do is I'll message Anna, and I'll send her a URL. She'll hit that URL, and now it's a malicious URL that I can now do some stuff to her. I'm not dealing with Robert anymore, so I don't have to worry about that protection. So when Anna hits that malicious URL, what I'm going to try to do is penetrate her network. All right, so let's learn about networks. This is your network. This is your network on drugs. This is probably most of your networks, actually, knowing you people. All right, so most networks have a NAT on them. Now, a NAT has a primary function. Just a quick overview. A NAT has a primary function. Basically, what it allows you to do is it allows you to take a public IP address and share it among multiple network devices. I heard a rumor the other day that we're running out of IP addresses. Has anyone heard this? So a NAT apparently helps push that out a little bit. So now, rather than having every single network device with a public IP address, instead, now we can have just one IP address and multiple network devices behind it. The NAT also serves as something else. What it does is, where before you might have your system, let's say your PC, and it would have a public IP address. What that means is that anyone on the internet could communicate with your machine directly. They could do any type of, if you were running some services, for example, they could try to attack it. If you had SSH running, they could try to brute force your login. If you had SendMail from 1984 running, they could exploit it. So there's a lot you could do, and that was sort of bad when we had public IP addresses. Now the NAT actually protects against that. The NAT sort of sits in front and says, whenever someone tries to connect incoming, the NAT will say, no, I'm not letting you in, assuming there's no port forwarding or DMZ or something like that enabled on the NAT. So essentially the NAT acts as an internet condom, if you want to call it that. Another thing is the NAT won't even know which device to send that traffic to. So if you just say, hey, I want to connect to you on port 80, the NAT will say, I don't know what device you're talking about. I'm not going to let this in. We're going to take a quick detour and talk about something called cross-protocol scripting. It's actually pretty cool. Now, one of the things about HTTP is that it is a new line-based protocol. All right, so what does that mean? What that means is basically every time you make an HTTP request of some sort, every piece of data you send is finished with a new line. So you say, I'm getting / HTTP 1.0 new line, or CRLF. Here's my user agent, new line. Here are my cookies, new line. All of that data is split by new lines. So when Apache or whatever web server on the other side is looking, it knows to look for the new line to signify, oh, there's going to be more data or new data here. Now, the interesting thing is HTTP isn't the only new line-based protocol. There are other protocols out there. For example, IRC. If you're familiar with IRC, I mean, obviously I love chat. IRC is Internet Relay Chat. It's a great way to, meet some really cool people. So IRC is also a new line-based protocol. Again, what that means is when you connect to an IRC server, you send some data and a new line, some more data and a new line. Well, what if we could control that with our browser? Now, the browser allows you to change a lot of the data that you're sending in that HTTP request, so why couldn't we send IRC commands? Well, let's look at an IRC connection. So an IRC connection normally looks like this. We connect to a server. We get a couple lines back from the server. We say, this is my username, this is my nickname. We might have to do a ping pong request. We join a channel, and then we send a message. Again, all with new lines, separating those commands out. Well, with HTTP, what can we do? As the author of a web page, what can we make the user's browser do? Well, let's say we have a malicious server. That was supposed to say HP. I don't know what happened there. So let's say this is our malicious server, and we can host some malicious HTML on there, or malicious JavaScript as well. What can we put on there? Well, what if we put a form on this page? And that form, all it did was an HTTP post. The post was to an IRC server, and the post data was IRC commands. What would happen? Has anyone here connected to an IRC server and accidentally sent an invalid command? What's happened? Nothing? An error? It errors and moves on. So what if we connect to that server, or let's say Anna visits our website, and what happens is that form automatically submits to an IRC server. So first, it sends the HTTP request, and it says post /. What's the IRC server say? I don't know what that means. I'm ignoring that. Then it sends the user agent, says, I don't know what that means. I'm ignoring that. Send cookies. I don't know what that means. I'm ignoring that. Until it gets down to the post data, which we control. That's just a hidden element on our page. The post data always comes after the HTTP request. So that post data gets sent. And what's that say? It says username. IRC server says, I know what that means. I'm gonna parse that. Then it sends nickname. Then it sends join. Then it sends private message. And at this point, you're joining a channel on an IRC network and sending messages. And the crazy thing is, it's not from you. It's from the user. It's from the user's IP address who visited your page. So what if you had 1,000 different users visit your website one day? That you'd have 1,000 IP addresses harassing some poor little IRC channel. What are some other, let's say, new line-based protocols? SMTP. What if you did this to a mail server? And you created a form that connected to a mail server that your browser thinks is an HTTP server, right? You say HTTP : / mx dot whatever, port 25. Your browser connects. It sends HTTP request, post, user agent, cookies. The mail server says, I don't know what any of those are until it gets to hello, mail from, recipient, data, subject, Viagra. Here's the code. It's that easy. All right, so why is this interesting? I mean, I really don't care about making Anna harass some IRC channel. I do that myself. So this is actually what the HTTP request would look like, right? You have all the post data, and then until you get to the actual post content, which is in red, and that's the data that the IRC server will finally say, oh yeah, I understand these commands, and then execute those commands. Well, the cool thing is what we can do is we can use something called NAT pinning, which is like